In this video, we'll be talking about a particular kind of sequence, the repeating pattern. A sequence is a list of entries occurring in a specified order. Sequences are important in math, and we start with sequences in the younger grades by looking at the repeating patterns. Here we have a bunch of examples of repeating patterns. Notice that our repeating patterns don't have to be numbers. We could have patterns that are actions, colors, words, shapes. We can have all kinds of entries on our list. So one thing that we do, especially in the younger grades, is predict what comes next. So let's look at these actions first. Stomp, clap, clap, snap, stomp, clap, clap, snap. What comes next? You can imagine doing this with kindergartners. And what we're doing here is keying in on the repeating unit. So we notice that every 4 entries, stomp, clap, clap, snap, we repeat. So we call this our repeating unit. There's our second repeating unit. And if we were to continue, we'd start again with stomp. Sometimes we label each entry with a letter. Stomp A, clap B. Because we repeat clap, we'll write B again. And then snap is a new action, so it'll get C. And we repeat as many times as we want to. This would be an A, B, B, C repeating pattern. We have A-B repeating patterns, A-B-B repeating patterns. We can have lots of different repeating patterns. In this next one, we could be looking at colors or we could be looking at words, and you can guess what comes next. Red, blue, green, red, blue, green, red, and we'd probably say blue comes next. Here our repeating pattern, red, blue, green, and we can continue on. We can get quite complicated. So in this next one, if you take a moment to analyze it, you'll see that the pattern repeats starting on the green triangle. So here we had 6, we could count 1, 2, 3, 4, 5, 6. Entry number 6 is where we finish our repeating unit, and then we start again. So we can count our entries. We can count just in sequential order, 1 through as high as we want to go. We can label each entry with a letter, which we then use to indicate when we have something that goes a second time. Here we had 2 B's in a row. So here we went triangle, trapezoid, rectangle, parallelogram, parallelogram, trapezoid, and then we repeat again. Then, of course, we can use numbers as well. Here I can imagine having students count off 1, 2, 3, 4, and then repeating 1, 2, 3, 4, and so on, and then having all the ones, for example, form a group. So these are all examples of repeating patterns. So let's go back to our red, blue, green pattern. It's possible to interpret this in more than one way. So I said the repeating pattern was red, blue, green, red, blue, green. So here we could continue that red, blue, green, and start at red again. But it's really important to define your repeating unit. Here I defined it as red, blue, green, but I could have defined it as everything that was listed and then just started over. So there I would have 7 entries in my repeated unit. And then if I repeated, I'd start at the beginning. The first entry was red, then blue, then green. Here notice that I have 2 reds in a row. So it's really careful to define our repeating unit because a student might surprise you and write down something you weren't expecting, but actually they would be correct if they defined this as a 7-entry repeating unit. So let's go ahead and define our repeating unit as just those first 3 words, those first 3 colors, and we say that this continues to repeat. So let's ask the question, how many blue entries will be in the first 20 entries? Take a moment to pause the video and see if you can figure it out. So let's start here actually with a common mistake. So somebody could get off on a good start, and they could start by counting the entries and then correctly saying we have 1, 2, 3 blue entries written down so far. But let's look at where the mistake comes in. This statement is correct. I have 3 blue in the first 10 entries, but the error comes in to say, well, I need 20 entries. And since I just doubled 10, how about I just double 3 to get 6? And then say, I have 6 blue in the first 20 entries. That feels like really reasonable strategy, but when we go to check it, we'll see that it didn't work. So I'm going to make a space for the first 20 entries, and then I'm going to make sure that I'm properly continuing my repeating pattern. Red, blue, green, red, blue, green, red, blue, green, red. So then I'm going to have to continue blue, green. My group was split here. Now when I go in and count, 1, 2, 3, 4, 5, 6, 7. I have 7 blue entries. So there was definitely something that went wrong here. So let's examine this further. Even though we work in a base 10 number system and we often count by tens, 10, 20, 30, in this case, the key repeating unit was 3 units long. So we needed to look and see how many sets of 3 are we going to have in the first 20 entries? And then we can start to figure out how many blue. So 10 isn't really relevant to our set of 3. I could have asked how many in the first 31 entries. And what we're really keying in on is how many groups of 3 are there in 20 entries. So let's do that. How many groups of 3 would be a division problem? 20 entries divided by 3 entries per repeating unit is 6 repeating units, and then we have a remainder of 2, so 2 extra entries. Let's go back and look and count. So we're going to count our repeating units. 1, 2, 3, 4, 5, 6, 6 sets of 3, and then 2 left over. So using this reasoning, if I have 6 sets of 3 and then 2 left over, I could say that if I have 6 repeating units with 1 blue per repeating unit, then I get 6 total blue. And I'll have to add, for those 2 additional entries, I'll have to add 1 more blue to get 7. So here again, the key was to look at how many sets of 3 do I have, and I know I'm going to have 4, 5, 6 sets of 3, and then I will have 2 left over. So I'm looking at the blue, 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 7 total blue. As you can see, it's important to have a firm understanding of multiplication and division, and these problems reinforce our multiplication and division. So as a reminder, With multiplication, we typically think of multiplication as the number of groups times the group size gives us the total. Here we're looking at number of groups or number of repeating units. And the group size might be the items per group, so I might have looked at, for example, 3 entries per group, or I might have said 1 blue per group. Both work to give me the total depending on what kind of total I want to get. With division, if we think about the how many groups perspective, we can say the total divided by the group size, in this case probably our entries per repeating unit, will give us the number of groups or the number of repeating units. Here's another problem for you to try. Stop the video and see what you can come up with. This one is really easy to make a mistake with because when we say today is Sunday, what will it be in 500 days? Well, in 1 day, it'll be Monday. Lots of people label Sunday as 1, either because it's the first day of the week or it is the day that's listed there. But in 1 day, what will it be? It'll be Monday. In 2 days, it'll be Tuesday, and so on. I know a week is 7 days, so I'm going to start over then. I'm going to repeat Monday, so I'll come down here. In 8 days, it'll again be Monday. So key here, my repeating unit is 1 week or 7 days. So I want to look at how many sets of 7 days are there in 500 days. 500 days divided by 7 days per week or 7 days per repeating unit. Let's do that calculation on the side here. So 71 total weeks or 71 repeating units, and we're going to have 3 extra days. So coming back here, I know that I'm going to have 71 full groups here, and then I'm going to have 3 extra days. So in 500 days, it will be Wednesday.